Falcon 9 is SpaceX's flagship operating rocket, and with just 2 decades of development and testing history, it includes engineering features that most other launch systems of its kind lack. This 2-stage medium payload lift vehicle is almost 100% reusable. As it stands, the Falcon 9 is one of the most resource-efficient and eco-friendly space launch systems ever built. In this video, we'll discover why it's so reusable and how it was designed to be so advanced. Don't forget to subscribe to 26 Dimensions, the space exploration and astrophysics channel here on YouTube. Falcon 9, its name inspired by the Millennium Falcon from Star Wars, stands at a height of over 150 feet tall and takes the trophy for the first ever rocket designed entirely in the 21st century. SpaceX first announced Falcon 9 in the early 2000s, placing it before NASA's popular Space Launch System, SLS, which secured government funding in 2011. Cutting-edge technology, as well as a nearly flawless mission success rate, have made the Falcon 9 the best choice of rocket for most commercial customers as well as many government-funded missions. Powered by SpaceX's crown jewel Merlin engines, 9 on the first stage and 1 after stage separation, the Falcon 9 runs on the combustion of cryogenic liquid oxygen and rocket-grade kerosene, a cheaper fuel than hydrogen, but generally prone to polymerization under high temperatures. The launch system features an advanced design built for maximum reliability and reusability. With just 2 stages, the number of negative incidents occurring on separation is significantly reduced, and Falcon 9 can still complete its mission if a couple of its engines fail. According to SpaceX CEO Elon Musk, many parts of the Falcon 9 can be reused up to 100 times, with more delicate parts like heat shields able to withstand about 10 launches before they wear down and become ineffective. This reusability aspect has made Falcon 9 very popular amongst its customers and given it a cutting-edge advantage over more polluting, wasteful rockets. Since the stages of the rocket can be reassembled and prepared for another launch, the overall cost of a launch is substantially reduced. The tank walls of the rocket are composed of an aluminum-lithium alloy, and the body is constructed through a popular friction stir welding technique, giving it remarkable strength and vibration resistance so that the stages land back on Earth in the finest possible conditions. Once the engines on the initial stage cut off, separation doesn't occur until all systems are fully operational and the correct trajectory for booster touchdown is acquired. Once the flight computer has go for stage separation, its pneumatic detachment mechanism kicks in. This section is composed of an aluminum honeycomb core and carbon fiber sheets, making it flexible and resilient, and the decision to use a pneumatic system instead of pyrotechnic fasteners for stage separation means the boosters can be detached very lightly, improving the chances of a successful touchdown. Falcon 9's second stage is a similar version of the first tank and uses almost identical materials and manufacturing techniques. This means that Falcon 9 pieces can be bulk produced, making it more cost-effective. Of the world's current launch vehicles, 75% of rockets failed in their first 3 launches. Falcon 9's first launches were complete successes, and it has had only 2 mission failures across a total of nearly 200 flights. SpaceX uses an uncommon method for releasing the rocket upon launch. Unlike conventional rockets, Falcon 9 is only released once engine burn is confirmed to be safe and all systems are functional. The engines can be automatically shut down and the propellant rapidly unloaded if there is any kind of malfunction on the launch pad, so that even if a flight would result in a failure, it is canceled before it can do damage. This is a system configuration often used on commercial aircraft, but rarely on space rockets. All this developed from a blank sheet to a first launch in just over 4 years between 2005 and 2010 for less than $300 million. Reusability actually makes Falcon 9 much more reliable than its competitors and prevents tragic accidents like the Space Shuttle Challenger explosion and Apollo 1 fire. Because most crucial parts of the rocket have been thoroughly tested and achieved good performance in flight already, they're more reliable in successive flights. The reused boosters have an edge over new ones because they've been flown and proven before, and are also therefore cheaper. Naturally, reusability and reliability means that SpaceX can launch many flights back-to-back to deliver payloads to orbit without having to extensively refurbish parts or build new launch vehicles. Overall, this makes SpaceX's Falcon 9 practically the best choice for payload delivery for most government and commercial applications since it is so safe, reliable, and cost-efficient. Hence why it is so great for launching Starlink satellites into orbit, because many payloads can be deposited very fast and at an affordable price. Over the past few years, the Falcon 9 has played a crucial role in making SpaceX CEO Elon Musk the richest man in the world and the most significant independent figure in the space industry. You've been watching 26 Dimensions, the space exploration and astrophysics channel here on YouTube. If you enjoyed this video, maybe you'll like other videos on my channel. Subscribe so you're notified whenever I upload anything new. Thanks for watching, and I'll see you next time.